This video will finish up 2.6, our section on Boxplots. Our first exercise, 2.6.2, is exactly like 2.6.1 in that we are going to be creating a modified boxplot. So this is what I consider our warm and fuzzy question for the first exam. And when I say warm and fuzzy question, I'm always very transparent, and there's one question I like to start the exam with. So it's the first page for every single student's exam, and that is the one that you should be getting a lot of points for. It's like a 10-point question, and we will have practiced it now 3 times in the lecture notes. We will have 2 different box plots that we create by hand on our worksheet on Tuesday, and you're going to have to do this 2 or 3 times in your homework as well. So when all is said and done, you will have done this 8 times as practice, not including all the sample exams. So there's no excuse to not do well on this question. So that's why I call it my warm and fuzzy question. In this particular question, we are looking at the amount that students spent on the last haircut, and we have divided up the males and the females, and we're going to go ahead and make our 2 box plots so we can actually see the differences in the distributions. We can kind of see them already looking at our stem and leaf plot. Looks like the women's our center's a little bit higher, and they're definitely skewed to those high values to the right, where the men are more symmetric. But we're going to see what differences we can really see from the box plot and see how that helps us. So we're going to first create and calculate our 5-number summary for the females, and then we're going to do the same work for the males. So just to remind us, our very first step of this question is making sure that we can read a stem and leaf plot. If you'll recall, every leaf here connects to the stem in front of it, and you can just glue those back together. So that 0 represents a 20. The next value would be the 25, and then another 25. And then we jump down to the next row where we have a 35, so forth and so on. One thing I do want to point out is students always get confused when they get down to this 9. There is nothing there. So what would happen in your data set is you're going to go straight from 85 to 100, and you'll just skip the 9 because there's nothing in that range of 90 to 99. So that's our female data. What you should do is plug all this in your calculator and then use 1-bar stats, just like we did in class on Thursday. And everybody should have a graphing calculator or the 36X Pro, so no one should have to do this by hand. If you were to do this by hand, I would highly recommend listing out all of your data in a row like we started to do up here at the top. It just makes life a lot easier than trying to work within the stem and leaf plot. A lot of mistakes happen when we're counting in a stem and leaf plot instead of just rewriting our data. So now I'm going to give you the opportunity to pause the video so that you can figure out the 5-number summary, check out those outliers, and then we'll come back and do the male data together. So pause the video now. All right, welcome back. Your 5-number summary. This is always the question that comes after the data for this warm and fuzzy. 2 pieces to it. One is knowing what the heck the 5-number summary is. It's those 5 things that go into our box plot, the min, Q1, median, Q3, and max. Those 5 values that divide our data up into quarters. And all 5 of them are available in 1-bar stats. So straight out of your calculator, you're just going, boom. Let me write this in. Our min was 20. Then we had a 36, 44, 56.5, and a max of 100. And that's the 5-number summary. This is usually like a 3-point question on the exams. Most of the points coming from these middle 3 right there. If you make a mistake, it's almost always somehow being off on Q1 or Q3 or the median. Our next question, our next part, is to check for outliers, which hopefully you remember the formula, or you could just grab it from the previous pages. For the lower fence, we start at the lower quartile and we go a little bit below it. For the upper fence, we start at the upper quartile and we go a little bit above it. So Q1 minus and Q3 plus. And the amount that we go below that lower quartile or above that upper quartile, that's 1.5 times our IQR. And again, this is something you just may want to put on your note card so that you don't have to memorize these particular formulas. So once we have that, we can just plug and chug, figure out what these fence formulas give us. So 36 minus 1.5. You'll know this is what I'm going to do on the test. There isn't a step where I ask you to calculate the IQR. You need it in order to finish this formula, so you should calculate it, but I'm not telling you to go ahead and calculate it. So remember, your IQR is Q3 minus Q1. And then we have our 56.5 plus 1.5 times my IQR. And those fence formulas should give you out 5.25 and 87.25. Now, remember, what the one piece that is missing here that would be on an exam is I always ask to identify the outliers. Like the question is, are there any outliers? Show me your work. So, don't like the question mark, but identify the outliers. So at this point, you just sit there and go, okay, look at my data set. Everything should be between 5.75 and 87.2 or 5.25 and 87.25. Anything that's not is an outlier, right? It's one of those bad sheets. So we figured out here 100 is an outlier. All right, moving on to the male data. Again, if you want practice, if you did something wrong on that first one, this is your opportunity to pause the video and try it on your own before we move together. If not, we will just charge ahead. Now, working with the male data, I could definitely see this mistake happening. I almost made it when I was typing into my calculator. This 1 and this 4, remember, this is still the stem, so that becomes 14. And then a 13, which is why if you were actually writing out your list of data here, you wouldn't want to start with the 4, you'd want to start with the 0 and work your way out. So 10, 12, 13, and 14 are those values. And then you got your 20, 20, so forth. But like the first thing I did was almost want to write 41 because I'd just done the female data. So once all is said and done in my calculator, I ended up with a min of 10. Q1 was 14, median was 22, Q3 was 33, and my max was 42. All right. Checking my stuff for outliers. We got our fence formulas again. Lower fence Q1 minus, upper fence Q3 plus, and 1.5 times our IQR is the rule. So we can plug into both of those formulas. Plugging into those formulas, I got negative 14.5 as my lower fence and a positive 61.5 as my upper fence. If we looked back at our data, right? In fact, one thing you can do if you don't want to actually go all the way back to the data is use your 5-number summary. That'll help you out with these fences too. So our lower fence is at negative 14. Well, negative 14 is below 10, right? So we can put that fence there. 61, well, that's somewhere here above 42. So all of our data, the min to the max, is contained within these fences. For the previous example, 5 is less than 20, right? But 87 is something less than 100. So you'd want to go back in and figure out what your adjacent value is, what that first good value was on either side, and see if anything else. It's possible to have more than one outlier like we did in 2.6.1. So now that we have all these fence formulas, and I guess I should write my conclusion here that there are no outliers for the male data, we're going to go ahead and we're going to make these modified box plots. We're going to go ahead and graph them on the same axes just so we can really compare the males to the females. So I need to be able to graph a minimum of 10 all the way to 100 if you think about both of these together. So I'm going to, at the bottom of the page, come up with this. So 10, 20, 30. Pretend these are evenly spaced. 40, 50, 60. Excellent. And I'll go ahead and do the females in red. So remember the order I like to do with this. The box, then the outliers, then the whiskers. So for the females, our box section, 36, 44, 56.5. So 36, 44, 56.5. That's our Q1, our median, and our Q3. Then we need to deal with our outlier. There was only one, and it was at 100. That's our max. And then we need to deal with our whiskers. So remember, the whiskers have nothing to do with the fences. They're the first good values, the lowest good value and the highest good value we have. Now on the low end, that's easy. Oh, failed. The 10 was for the men. 20 was our minimum for the ladies. On the high end, though, our maximum was an outlier. So we can't use that 100. We can't go there with our whisker. Instead, we need to look back at our data, say what was the first good value. And remember, we drew our fence here. The first good value was 8, or the largest good value was 85. So we're going to go to 85 with our other whisker. And then we're going to go ahead and graph the men. So start with the box. We need to go from 14, 22 to 33. And there were no outliers to deal with, so we go straight to the whiskers, and there's nothing funky going on. 10 all the way to 42. Our min, our Q1, our median, our Q3, and our max. So that just lets us really see the drastic differences between the men and the women when it's the amount they spend on a haircut, right? Our entire upper half for the women, for the entire upper half, our entire middle half for the women is above the entire middle half for the men. So 75% of women spend more than 75% of men. That's a big difference, and one that wasn't incredibly obvious looking at our stem and leaf plot, but very obvious looking at our comparative box plots here. So I'll go ahead and do 2.6.3 and any other exercises for 2.6 in a second video so we can break this up a little bit.